All right, hey everyone, this is the short recap of week 28 of my kernel development streams. This episode, I think, is one of the best ones I've ever had. I'm super excited about this episode where we set up interrupts in a pretty basic way, and I've been looking forward to doing this for a long time. So basically, I'm working on exercise 4 from lab 3 from the MIT operating systems course from 2018. And I spend a good amount of time at the start just kind of orienting myself with the assignment and the problem. And the assignment is to basically implement like support for interrupts, like be able to have run a user program that does a division by 0, and then have the operating system's interrupt and exception handling infrastructure activate and handle that exception, where previously it would just trigger like boot loops because there was no interrupt handling infrastructure at all. So I spend a decent amount of time just kind of orienting the code and exploring the code. It's probably the first 17 minutes or so. Here I am playing around with the assembly portion of the interrupt support, kind of getting my bearings. Specifically in this assembly portion, we need to use some macros to generate some handlers basically for the specific interrupts. And then separately there is an assembly routine that all of these handler stubs jump to. So, but here I'm just kind of getting oriented and writing the basic macro for the divide error. And that's what I do in this whole stream, is just basically set up things working for the division exception, like the division by 0 exception, and that's it. So just more rummaging around the code, around the 22-minute mark, looking at where the IDT is defined, the interrupt descriptor table, which is a pretty important structure we have to work with. Here I am beginning to sketch out the alltraps function. There's like, I didn't really know how to do this because it requires writing some assembly, but some parts are pretty easy. Like the last 2 things we need to do are just push ESP and then call this trap function. So that's pretty easy to just kind of sketch out and get a skeleton going. What I didn't really know was loading this kernel data descriptor into some segment registers, and also this pushing values to make the stack look like a trap frame. That was more advanced stuff I got to later. But I just started out with doing what I could. So there's that. And here I'm like looking and referencing how other parts of the code kind of work with the setting the descriptors, setting the segment registers. Here I'm just taking some screenshots of all parts of the code to kind of have one place where I can see a lot of different things at once, which is something I like to do. Here we are looking at the structure that models the x86 interrupt descriptor, or interrupt and trap descriptor. And yeah, just kind of looking at where things are initialized. Yeah, here we're going into the manual and kind of getting the official documentation on these structures. Yeah. And then here we're looking at this macro that's used to set up the interrupt descriptors. So it's called setGate, and it uses this gate descriptor structure on the right. So just kind of understanding how that works as a kind of a convenience helper for constructing the interrupt descriptors, basically. And then here we're just kind of comparing the type declaration to the the diagram. And then now it's like kind of, I try to start coding. So one of the first things to do is actually start to set up the IDT. And I'm just going for as simple as possible, going for the divide by 0 exception to start off with. So I'm just setting up the interrupt descriptor for that. And that basically just looks like calling the macro with a couple of different arguments. That's around the 1 hour mark, 56 minutes. Eventually I do get that done, and I move on to, I guess, yeah, like just debugging the kernel, making sure that observing that works. Yeah, there was like a bit of a question about why it's okay to not pass a pointer, but it's because it's a macro. That's a bit of a detail. And then I just kind of keep moving on, and I kind of go through what the assignment tells me to do. I start going back to this assembly because that's actually the last of the 3 things. At this point, I had done the initial macro above for kind of declaring the stub. I did the C code support and trap init to set up the the interrupt descriptor, and the last part is writing the alltraps assembly code to actually call into the C trap handler. And that took a little bit of time to figure out how to move variables into other variables, which I kind of forgot how. This is my guess at how to do that. And then was kind of for the fun part of trying to set up the trap frame, which was just some reading around the 1 hour 20 mark. I did this whole set of diagrams to help explain that. And I was, just pushing some data onto the stack to construct a trap frame, which will pass to the caller. So that's pretty interesting. 1 hour 31. Running into some issues with Intel versus AT&T syntax. And then I write the final kind of code around 1 hour 40 minute mark. And then from there on, it's just kind of debugging how to actually get this working. I had this panic such that it would just panic when we made it to the actual C trap handler, which was the goal. And then I kind of set up the kernel to load in the user program that does a divide by 0. That took a little bit of time. Pretty nifty in GDB. We can just do prints, and it prints out the whole structure and stuff. So that's pretty cool. What I ran into is that actually this divide by 0 program was not doing a divide by 0. Actually, it was getting optimized out. So I was trying to figure out how to reduce optimization, but even then it wasn't generating a divide by 0. So I ended up needing to reach for inline assembly to do that, and I was trying to figure out how to do that. That's around the 2 hour mark. I eventually did figure out how to do the inline assembly to trigger the idiv instruction and stuff. And then at the 2 hour mark, it hit the idiv, and it actually worked. It actually started to go into the stub, which we can see right here, the divide 0 interrupt stub. And then the rest of the stream from the 2 hour mark, 158, to the end of the stream is me debugging why this wasn't working. It was like triggering reboots. And it's just because I was actually using the wrong instruction in my assembly. This was actually dereferencing 0 instead of using a 0 constant. And so I just kind of was debugging that for the rest of the half hour pretty much. And yeah, eventually I do figure it out. Maybe I'll just play the last bit. I eventually learned how to write assembly better and stuff, and maybe I'll just play the end. So that's, I guess, all the way at the end, so I have to back up a little bit. Okay, we made it. We're now in trap. And what happens if I continue? Made it to the trap function. Hell yeah. Made it to the trap function. We did it. We did it, guys. That's so sick. All right, I'm going to end the recap here, but that was a short recap of today's stream. Thanks a lot for watching, and like, comment, subscribe. I'll see you in the next time. Peace.